Oh, welcome and thank you for joining. In this lesson, we'll explore how to operate with radical expressions. Our focus will be on multiplication and division of radicals. If we're multiplying two radical numbers with the same index, then these two numbers can multiply together and go inside the same radical. So in other words, we're going to say the nth root of a multiplied by the nth root of b equals the nth root of a times b. Similarly, if we are dividing two radical numbers, index has to be the same, then we can write this as the nth root of a divided by b. So in the first example, we're asked to multiply these two radical numbers and express as a single radical. So we have multiplication. The index is the same. We don't see it, but it means that that's 2, which means that we can write this as the square root of 5 times 7. And more simplified, square root of 35. In the next example, example B, we have the square root of 3x to the 4 times the square root of 5x to the power of 2. So since the indices are the same, so second root, then we'll write this as the square root of 3x to the power 4 times 5x to the power of 2. Simplify, numbers will go with numbers. 3 times 5, 15. X to the power of 4 times x to the power 2 is x to the power of 6. And this would be the answer. So next, we'll try the square root of 2a3b times the square root of 7a4b6. You can try this on your own, obviously, and then follow with the solution. So I will continue explaining it. So we have the product, we have the same index, which means that these two radicands can come inside the same radical sign. So we'll have the square root of the product of the two radicands. So now we have to simplify. So 2 and 7 will multiply together to give 14. A3 and A4 will multiply to give a to the 7th. And b to the power of 1 with b to the power 6 will give b to the power of 7. So in the next example, example number 2, we have to divide and express the answer as a single radical. So we have the square root of 48 divided by the square root of 3. So that would be equal to square root of 48 divided by 3, or simplify the radicand inside. We have the square root of 16, and that equals 4. The answer is 4. So we didn't need to leave it in radical form because it became even simpler. So next example, we have the square root of 75x to the power of 6 divided by square root of 3x squared. Again, both are radicals with same index, index 2, which means that they can come inside the same radical. So we have 75 over 3, that's 25x to the power of 6 minus 4. 2, which is 4, and the square root of 25 is 5. The square root of x to the power 4 is x squared, so 5x squared would be the answer. Now your turn, try one more question. So we have the square root of 80a to the power of 4b divided by square root of 5b. So same index, which means they can come inside the same radical, and we have 80a 4b divided by 5b. So simplify, 80 over 5 would be equal to 16. A4 will stay A4, and the b's will simplify. So we can simplify a little more, that because we have the square root of 16 times a to the 4, which is basically the square root of 16 times the square root of a to the power of 4. Square root of 16 is 4. Square root of a to the 4 is a squared, and that would be the answer. So in the next part of this lesson, we'll look into pure and mixed radicals. Pure radicals are also known as entire radicals. In a pure radical, the radical number will have a coefficient of 1, which in other words means that the entire radical number is inside the radical sign. That's why we call it entire radicals, because there is no other number besides it. In a mixed radical, we have a mixture of a radical number and a regular number, so to speak. So we have the product of a number, a non-radical number with a radical, and that's why we call it mixed, because they're mixed together in a product. Now, a radical number is considered to be in the most simplified form if the value of the number inside the radical is the smallest it can be. So for example, this entire radical in here is not considered to be the most simplified because we can break this down into root 4, root 7, and that will change to 2 root 7. Now, this would be the simplified form of the radical square root of 28. So we want the expression or the number inside the radical the smallest possible. A radical expression, on the other hand, is in the most simplified form if the expression inside the radical is in the most simplified form it can be. And there are no more factors that can be taken outside the radical. So let's take a look at some examples to see what that means. So we have to express the given numbers in here. As you can see, they're all entire or pure radicals in the most simplified form, which means that all the numbers inside the radical or the radicands must be converted to the smallest possible or reduced to the smallest possible. That would be the correct word. So how do we approach this? Step number 1, we have to identify the index. That's very important. So in the first example, as you can see, we have the square root. That means the index is 2. So because the index is 2, and we know that the square root of perfect powers of 2 would be equal to that base in here, right? Then we will have to search for perfect powers that are factors of 18. And the way that I like to look for the perfect powers is by just making a small list of them. Now, the bigger this number, the bigger the list of perfect powers that you will need is. But in this case, we have a small number, so we have the perfect powers. We don't count number 1 squared as a perfect power because it doesn't change the value of the number, the multiplication by 1, we mean. So I would look for power of 2, perfect power of 2 is 4. 18 is not divisible by 4, so we cannot break this down into 4 and something else. Then the perfect power of base 3, 3 squared is 9. So 9 is a perfect number. Is it a factor of 18? Oh, yes, it is. So therefore, we're going to write number 18. And that's what we explained here in the next step. So we have to identify the index and then divide the radicand by the perfect powers of the index, which means that we're searching for the factor. So 18 divided by the perfect power of the index is 9. So the two factors will be 9 and 2. Now, based on how we multiply two radical numbers, so the square root of 9 times 2 would be square root of 9 times square root of 2. So we can split them, and that allows us to find the square root of this perfect square, which is equal to 3 root 2. So next, we'll continue with the square root of 363. Now, if you understood the steps, always attempt to do them on your own. It is more interesting, and it's a richer learning experience because even if you get it right, obviously, it's exciting. But even if you get it wrong, then you will learn how not to make those mistakes, before you write a test. So the square root of 363. So if the index is 2, it means that we're looking for powers of 2. So we'll start off by listing all the perfect powers for 9, 16, 25 powers of 2, right? 36, 49. So you list them and you divide 363 by each of them to figure out what the other factor might be. And that's what we mean here in step number 2. And then in step 3, you will rewrite the radical number as a product of two radicals and simplify. So let's take a look at what we obtain in here. 363 is 121 times 3. Remember, 121 is perfect power of 2 with base 11, right? So now we can split it into root 121, root 3, 11 root 3. This is as small as it can be, and that's the most simplified form. Let's go third root of 54. So the story changes here a little bit. So we have to identify the index is 3. So we're looking for powers of 3. So 2 to the power 3 is 8. 3 to the power 3 is 27. Now with small numbers, you cannot go above, let's say 54. 4 to the power of 3, that's 64. You don't need to actually go over this number, so check this number because it is bigger than the radicand, right? And we're looking for a factor of the radicand, so which means a smaller number than what the radicand is. So we'll rewrite this as the third root of 27 times 2. Remember, 27 times 2 is 54. And then we'll split it based on the product formula as third root 27, third root 2. And that would be 3. That's what we obtain from third root 27, is the third root of a perfect cube. So that would equal the base root, the third root of 2. Now, let's do one more example. Now we have index of 4, which means that we're looking for perfect powers of 4 to be the factors of 80. 2 to the 4 is 16. So 80 divided by 16 is 5, which means that we can write this as the fourth root of 16 times 5. I made a typo in here and I pre-wrote them, so we'll try to correct it. And that would be equal to fourth root of 16 and then fourth root of number 5. Now, fourth root of 16 is equal to 2, and this would be the fourth root of 5. We'll move on to our next example, which is the third root of the fifth root of 320. So now we're looking for the perfect powers of 5, right? So 2 to the power 5 is 32, and look no further because you can see that 32 is a factor of 320. So we'll break this down into 32 times 10. So 320 is 32 times 10, and now we'll apply the formula for the product of two radicals. So we have the fifth root of 32 times the fifth root of 10, and fifth root of 32 is 2 multiplied by the fifth root of 10. So moving on to our next example, example 4, we have to express as entire radical. So we're doing the opposite this time. We have a mixed number or a mixture of a radical with a regular or whole number, and we have to write it in radical form, which means that number 3 must be expressed in radical form first. And the radical form we're looking at is the second root or the square root. So in order to bring number 3 inside the radical, we need to bring number 3 to the power of 2. So step number 1 in this case would be to identify the index, which we did, and bring the number outside the radical to the power of the index. So we're going to bring number 3 to the power of 2. And then write this in radical form. So the square root of 3 squared would be equal to 3, and we still have the square root of number 2. So let's write this down. So we have the square root of number 3 to the power of 2 still multiplied by the root of 2. So these two are the same. And now we can simplify a little more. So that's the square root of 9 times square root of 2, and now we can bring them inside the same radical because they do have the same index as the square root of 9 times 2, and that equals the square root of 18. This can be can be done a lot faster, but I'm just trying to show the steps. In case you're wondering what steps you need to show, it is important that you show this step in here and this step in here, or alternatively like this one here and this one here. It is the same thing. It's a 2-mark question. So in the next example, we have the a square root of b. So index is 2. Therefore, we're going to need to write a inside a square root. That means we have to give it a power of 2. So there we go. We have a written as the square root of a squared, and then multiplied by the square root of b still. So bring them inside the radical, the same radical, a squared b, and voila, this is the answer. Now, in the next example, we have 2y squared, the third root of 3y. So if it helps, keep these terms in brackets, okay? And what we'll do is we'll identify the index first. The index is 3, which means that we need to rewrite 2y squared with index 3. And if we want to keep the same value of it, 2y squared must be brought to the power of 3. So let's do this. So we'll rewrite it as the third root of 2y squared to the power of 3, and then multiply it by the third root of 3y still. Now, we'll simplify this a little bit, if possible, and remember that power of 3 will apply to number 2, which is a coefficient, and y squared, to give 8y to the power of 6, and then times the third root of 3y. So now it's time to multiply the two radical terms and bring them inside the same radical. So we have the third root of 8y, 6 times 3y. Now combine these together, and numbers will go with numbers. 8 times 3, 24. y6 times y to the power 1 is y7. So the third root of 24y to the power of 7 is the answer. I hope this made sense and you found it interesting. Practice some questions from the suggested practice homework questions and see how you do. Bye for now. Thank you for learning with me.